Welcome to this special episode of our podcast from the Energy Consortium at IIT Madras. In this series, we will dive into cutting-edge research and innovations that are going to be shaping the future of energy, sustainability, and climate action. The Energy Consortium is a collaborative platform bringing together researchers, industry leaders, and policy makers to address global energy challenges through multidisciplinary solutions. In this episode, you will hear from specialists in energy. So let's get started. Dr. Sudharshan Saranathan is a researcher at the Energy Consortium, where he works on the Climate Action Tool, a platform for modeling and analyzing energy systems. His work focuses on leveraging data-driven insights to support sustainable energy transitions and climate policies. Hello, Dr. Sudharshan. Thank you for taking the time to speak with me. To start with, could you introduce yourself and tell me about your role at the Energy Consortium?
Thank you. It's a pleasure to be here. My name is Sudharshan. I joined the Energy Consortium last year in April. I'm working as an R&D specialist, and my work focuses on this particular project that we are developing called the Climate Action Tool. It is a modeling platform as well as an analysis platform where we collect data from different sources that are available in the public domain and data pertaining to industrial sectors. And the platform also facilitates modeling and analysis specifically related to decarbonization and energy transition strategies. So that's primarily what we are developing and what we have been developing for roughly more than a year or so. And obviously it's going through a lot of development cycles and iterative improvements. So that's currently what I'm focusing on.
Sounds really interesting. So what is your main area of research focus?
I would say is decarbonization studies or energy transition studies. We know that in the context of climate change, there are a lot of companies, industries that are slowly trying to move away from carbon-heavy processes. Roughly, these are called decarbonization. And this is obviously a quite complex topic. So industries, they also have additional objectives. For example, they have to maintain profitability. They have additional goals and priorities. And on top of that, this decarbonization is now one more objective. So there is a need for systematic analysis of how to go about this, of finding ways that balance several competing objectives so that decarbonization is not solely focused but due importance is given to all other objectives as well. And such an analysis obviously needs to happen in a very quantitative manner. So we need to have data-backed insights so that they can be effective and we are able to meet our decarbonization targets in the future.
That's very exciting. So energy systems are considered to be very complex. So why do you think it is essential to be able to model them effectively?
So the target, because we have to decarbonize and we have to transition away from fossil fuels, all countries in the world almost are looking to go towards renewable sources of energy. They are looking to wean off fossil fuels, transition to alternative fuels, for example, green hydrogen or any other forms of hydrogen. And in order to do this, obviously, we have to first of all map how these different systems are connected, because when we make decisions for a particular industrial sector, it's not that the ramifications or consequences of those decisions only affect that particular industry. There are ripple effects that propagate to other sectors as well, and that is one of the main reasons why modeling is complex. And so when we look at decarbonization, there is a need to move away from very focused or narrow decarbonization of specific sectors, but also pay attention to decarbonization on a holistic scale. So when we take into account the effects of one industries on all industries, that means we have to model multiple sectors at a time, and all of these basically makes it complex. And when we try to optimize, when we try to provide suggestions for how to transition to a greener pathway or how to switch your fuels or something, then we can derive better insights because of this holistic modeling than if we were to take a look at specific sectors alone. So that's primarily why we do this complicated modeling, or we develop platforms where we analyze a large amount of data, and then whatever insights we generate, we tend to, or we try to cultivate or generate these insights based on holistic modeling rather than a focused single sector specific modeling.
It's really exciting. So are there any specific projects that you're currently working on which you're excited about and would like to share with us?
Working on is the climate action tools. It's a modeling platform that we have a software team, we have modelers and different teams that work on different aspects of the project. And this is something that I'm really excited about, because it is going through it has already gone through significant development, and I think it will continue to do so. And using this tool, we've actually already applied it to certain specific cases. For example, the government had introduced the Perform Achieve Trade scheme, which was quite old in the previous cycle. And using this tool, we were able to understand what were the effects of that particular scheme, whether it was sufficient, whether it could have been a little bit more aggressive in the targets that it set for these different sectors. But also, we are using the tool to also study other sectors. For example, we have a team where different people work on different sectors. So one such sector that I had worked on was trying to understand how the urban heat island effect can be mitigated, where cities, because of construction or concrete or certain kinds of materials, they tend to be hotter than rural areas, comparatively speaking. And because we have urbanization that will continue to grow, we'll have more and more urbanization in the coming decades. That means more and more buildings, more and more concrete, and so on. So we can anticipate that cities might get hotter. So the question is, how can you still account for this growing urbanization but without letting the ambient temperature rise too much? What kind of solutions can we pursue? And in order to answer this question, we first have to model how energy, which is primarily a city, is heated up because of solar energy. So we can use this tool to model how the energy flows through the different components in an urban layout, say trees or water or concrete buildings and so on. And depending on that, we can sort of propose solutions and also find out how to optimize them so that we, again, reduce the cost of implementing such solutions, but also the main objective, which is to keep the temperature at a minimum. So that's an example of a project that I had worked on earlier. But we are also using this tool for other sectors. We have schematics of cement manufacturing, steel manufacturing, thermal power plants. So these are a lot of things that I'm excited about, and I think we'll continue to expand the base of projects that we cover. And
very inspiring to hear about the work that you're doing. So before we wrap up, is there anything else you would like to share with us?
I'd like to just state that we really expect the climate action tool to become a very powerful platform for modeling and analysis. We hope to be able to drive decisions on a very high level through concrete data-driven insights, and I would hope that the tool evolves to that stage where it can be heavily deployed in industrial sectors and for routine decarbonization or energy transition analysis.
Great insight. Thank you so much for your time, Dr. Sudharshan. Appreciate the conversation and looking forward to see how your project is developing. Thank you very much.